Hi everyone, let's do the worksheet together. Okay, so let's do problem number 1. It says the standard IQ test is a common exam used to measure a person's intelligence quotient or IQ. The scores are approximately normally distributed, normally distributed, with a mean of 100. Okay, so we have a mean of 100. What else? And a standard deviation of 16. Okay, cool. What is the probability that a score chosen at random, so we'll let x equal IQ scores, right? What is the probability that a score chosen at random will be an IQ score of less than 84? So what's the probability that x, which is the IQ score, less than 84? Okay, less than 84. Cool. So let's fill in our template. So we got 100, right? And then we got to subtract 16. So subtract 16 from 100. Or no, add 16 to 100, right? It's 116. Add another 16, it's 132, right? And then we're going to subtract 16, that's 84, right? And we're going to subtract another 16, that's what, 68, right? 84 minus 16, what's that, 4, 5, 6, 8, and then that's a 7, that's a 6, right? See that? Okay. We can use our calculator too, but we're using our mind. We're going to shade 84. So we got to be very careful. It's not this 84 that we're talking about because that's percentile. We're talking about this 84. Okay, so it's less than 84. So we're going to have to shade less than 84. Right? Isn't that cool? Okay. That means we shaded, let's see, hold on. We shaded, no, this pencil. We shaded 13.5 plus 2.5. That gives us 16%. So this answer should be very close to 16%. Let's find out. Okay, so we gotta go normal CDF, right? Lower bound is negative infinity because it goes all the way to, this shaded piece goes all the way to negative infinity. The upper bound is where it stops on the right. That's what, 84? Okay, what else? We need to know the mean, which is 100. And we need to know what? The standard deviation? 16. Okay. All right. Let's see if this works because the other program doesn't work. Let's see. Can we go side by side? Haha. There you go. See? That's neat. All right. Kind of. Yeah. All right. So we go with second bars, normal distribution. We got to go with negative EE 99, right? Watch the videos if you don't know how to do that. It's important. We'll talk about that. Negative infinity, 84, comma, 100, comma, 16. Close it, enter. Haha, awesome. So we got an answer, right? What I'm going to do, I'm going to move this over a little bit here. The answer is point 0.15865. So, what are they asking for? What is the probability the score chosen at random will be an IQ score of less than 84? What's the probability that a score chosen at random? So not so 15.865%, right? Will have an IQ score of less than 84. So 16% will have an IQ score of less than 84. And that's this 16%. Okay? And if you can elaborate the sentence even nicer, by all means. But that's it. That's the type of information you need to show for the test. Because in reality, all it is you're plugging in the numbers in your calculator and it's giving you the answer, which really doesn't help in learning. You need to know what that number really tells you, or how did you figure out that number. And if you demonstrate the shading piece and the writing the sentence and writing out like what you did on your calculator, it provides a way of telling people that you are understanding the problem. Okay, so let's move on to the next one. All right, the next one says, suppose you are a marine biologist studying a particular species of whales. The average length of this whale species is 60 feet. So definitely we're going to need 60. One thing about these problems, it says average length. And so this doesn't say in particular like you're studying 10 whales or 15 whales. We're talking about the species, like the whole population of the whales. So the mean is 60, so the population mean. And the standard deviation is 12 feet. The standard deviation is 12 feet. The average length of a whale is normally distributed. And so that's another key to tell you that these are the parameters. These are, population distributions. Okay, what else? Find one member of this particular species of whale and measure it to find its length is 48 feet. Okay. What is the z-score corresponding to the length of the whale? Okay, it didn't say what's the probability, of less than 48 feet. It didn't say anything like that. It said, what is the z-score? Well, there's only one formula for the z-score that we know of. Z equals what? X minus mu over sigma. Okay, good. So X is what? 48 feet. Subtract mu. What's mu? 60. What's sigma? 12. Okay. 48. Take away 60. I would enter. Then divide by 12. Minus 1. I don't think the calculator is that smart algebraically. Yeah, see? Don't do this, because it gives you a whole different answer, right? Because it's dividing 60 divided by 12 first, which is 5, and then subtract 5 from 48. 48 is 43. So if you're going to do something like this, put parentheses first to tell the calculator, hey, subtract this first and then divide by 12. There we go, you see? These are some of the simple things that happens and you make that mistake. So the answer is 1. So the z-score is equal to -1. Okay, that's it. We don't need to do anything else. All right, let's see. What else? Okay, that's not bad, right? I mean, yes, you need to understand what is going on. And that takes a little time. So you should always go back to the videos and watch that segment on the z-scores. Okay. What else? What is the probability you find a whale? Find a whale. Find a whale greater than, right? Greater than 84 feet. So we know mu is 60. We know sigma is 12. We know that x is equal to what? The whale, right? Whale length, right? So this is the whale length, the average whale, the length of the whale, okay? And then we want, what's the probability that the whale length, that's what x is, right? X is the what? That's right, random variable, which is this random variable. The whale length, the probability of the whale length is greater than 84 feet. Well, first of all, we need to make sure that we have the proper template filled out. You have to fill it out. So what do we got? Mu is what? 60. Add another 12 is what? That's right, 72. Add another 12, 84. Just like your multiplication tables. Subtract 12 from 60 is 48. And subtract 12 from 48 is 36. If you need to use your calculator, then use it, right? 60, take away 12. Okay. Subtract 12. You didn't think you can do that, but you can. 60 plus 72. No, what am I doing? 60 plus 12, right? 72 plus 12, 84. See that? Pretty straightforward. Ooh, okay. Now the orange. All right. So 84, greater than 84. So we're not talking about this 84. That's very important. We're talking about this 84. And this is the reason why I did it that way, so that you understand the difference. We're talking about the whale length, not a percent or percentile. Remember, these percentiles are probabilities. So are these, right? Make sure you watch the video on that. Okay, greater than 84. You see how greater is this way and it's pointing to the right? That means you're going to shade to the right. Also, these inequalities, you have a chart that I gave you. Is it what, symbols to words or something, or words to symbols? That chart will tell you what does it mean by greater than. Okay, so we're over here. This is 84 right here, right? That's 84, and then we're going to shade this piece. That piece is 2.5. That's right, 2.5. 2.5%, okay? So this is the approximate answer, right? Is it correct? I don't know. So we need the normal CDF. We need the lower bound, which is 84, because that's the lowest value of the shade. And then it goes up to what? That's right, infinity, positive infinity. You don't need a plus. Then mu, 60. And then sigma, which is what? 12. Okay, let's use your calculator. Let's see. What do? We go to second, bars, normal CDF, 84, comma, positive infinity, so second, double E, 99, comma, 60, comma, 12. You can close it. Enter. Aha. What do we got? That's going to be 0.02275. Ooh, that's really close to 2.5%. Very close. All right, let's write a sentence out. We got 2.275%, right, of whales have a body length greater than 84. That's not too bad. Well, not the best sentence in the world, but it's good enough. Okay. Excellent. Yeah. So approximately 3% of whales have a body length greater than 84. Now, here's something. Do not round, okay? Don't round this to 3%. That's important. Okay, let's move on to the next page. Okay, what do we got? All right. The length of human pregnancies is approximately normal with a mean of, okay, mean of what? 266. And a standard deviation of what? 16 days. Okay. If a baby was born on the 2.5 percentile, approximately many days, approximately how many days was the pregnancy? Ooh, see, that's good that I found out. Approximately how many days was the pregnancy? I'm going to change that. Sorry about that. So, what could be the answer? 2.5 percentile. You got to watch that video to know what percentile means, right? The shaded below. So, 2.5 percentile, is it over here or is it over here? Well, it's percentile, meaning shaded below. You start from negative infinity to up to 2.5% in this case. So it's this piece right here. This is the shaded piece. But what do you want? How many days? Well, we don't even have the days written down over here. So let's write them out. So we have 266, right? And then we're going to add 266, right? We're going to add what? 16. That gives you what? 282. Okay. And then we're going to add another, what, 16, right? 298. This is cool, isn't it? Then 266, we're going to subtract 16. What's that, 250? And we're going to subtract another 16. 234, right? 234. And now we know. You see? Now that we have this shaded piece, where does it land on the right? Because that's percentile. Percentile is shaded below. It's shaded up to this point, right? So the answer is going to be what? 234. 234. Well, let's write it in black. So it's going to be 234 days. Now, that is an approximation, right? That gives us a sense of, okay, this will be the answer, very close to the answer. But how do we find the answer in the calculator? Is this a normal CDF problem? If you haven't watched those videos, you got to watch them. I can't stress you enough. Yes, they are long, but they're worth it. Okay? All right. So what are we thinking here? What do you think? That's right. Inverse normal. The inverse normal. Now, I just thought of something. Hold on here. Okay. This is pretty important. We are given percentile. Okay, we're given percentile. And we want to go where? We want to go to X. Oh, here, you see? How many days? Percentiles, how many days? That means we're going to be using the inverse normal. You need a percentile, mu, and sigma. Okay. All right. Well, see, it was useful doing all that. So that's why we're using the inverse normal. So we're going to need the percentile, right? So 2.5 divided by 100 is 0.025. 0.025. It's important that you use not the percent, not 2.5%, but the decimal version. And then we got to use, do you remember what it was? That's right, the mean, 266, and then the standard deviation. Okay, let's find out. Second bars. Ah, look, inverse normal, right here, number 3. Perfect. 0.025, comma, 266, comma, 16, close it, enter. Aha, there it is. The answer is 234.640. Pretty neat. Very close to the answer, to the approximate answer, isn't it? That's pretty awesome. So there would be, what, 234 days is the approximation of how many days was the pregnancy, right? So the babies are born, if the baby was born on the 2.5 percentile, then it would be 234 days approximately, right? So, and in reality, if a baby was born on the 25th percentile, yeah. So if the baby was born on the 2.5 percentile, they would have a pregnancy length of approximately 234.640 days. Wow, that's a lot of words. Do your best, okay? Let me put this, that we need to change that. So it says, if the baby was born on the 2.5 percentile, they would have a pregnancy length of approximately 234.640 days. That's pretty good. That's good. I mean, it really tries to be as concise as possible, okay? Again, we're not experts in babies or pregnancies or anything like that, but you can create a sentence that conveys what 234 was, right? That's very important. Okay, let's do number 3B, right? Yeah, it is time consuming. And yes, you will have these on the test or something like it. Part B. Okay, so part B uses mu is equal to 266 and sigma equals 16. And I know some of you will email me. They're going to ask me, hey, can we just like use the first one to shade it? No. Do I have to draw a new one? Yes. Okay. So 266, 282, 298, right? 250, 234. The cool thing about using a tablet or something, you can always copy and paste your template. If you don't, it's not a big deal. Okay, so it says, what is the probability that a random pregnancy has a length between, keyword, 250 through 290 days? So the probability, and one thing that we didn't do over here, right? X equals number of days, right? So number of days of the pregnancy. I guess we can write that down. Pregnancy. Okay, so X is between what? 250 through what? 290, isn't it? Yeah, 290. Now, if you watched my videos, we talked about between as a key word that shows you the inequality. You got to go back and watch those videos again, all right? But between, well, X is between two numbers, and the inequalities are pointing a certain way. Watch that video again. It's going to be important. Now, what are we going to shade? We're going to go from 250 to 290. From 250, which is right here, to what? 290. 290 is like, 290 maybe like right here or something, right? Maybe? Something like that? Okay. So, let's shade. We're going to shade this piece. We're going to need 34. Okay. Don't you think these graphs look nice? It's pretty cool. So crazy. Here's another 34. I mean, we're going through this whole process of the curve. And we want the curve to go down, right? And then we're talking about, what are we talking about here again? Pregnancies. We use the curve for that too. Okay, 34. 34 here, 34 here. What else? Well, here's the thing that I was talking about last time. We're going to shade, right? But we're not going to shade all 13.5%. So that's less. Okay. So, let's see. Let's move this over. Move that over here. So we got approximately what? 34 plus 34 plus, I'm going to say, I don't know, 10%. Right? I think that this is 10% shading. I mean, if you say 9, that's fine. If you say 13, probably not. If you say 2%, no, it's not. Okay. 34 plus 34 plus 10, 78. So I'm thinking it's 78% is going to be the answer, right? That the pregnancies 78% of pregnancies have a length between 250 through 290. Well, I don't know. We're going to need to use our calculator. Normal, CDF, okay, normal CDF. We need the lower bound, which is what? 250. I know a lot of things to take into consideration. The upper bound, what is that? What number is that? 290. Hey, 290, just like what we wrote here and the two numbers in between. But you got to be careful, okay? And I'll tell you a little more about that later. Then we need 266, which is what? The mean, and then 16, which is the standard deviation. Okay, normal CDF. Second, bars, normal CDF, 250, comma, 290, comma, 266, comma, 16, close, enter. Aha. So we have an answer, and I usually put an arrow, an answer of 0.774537. Ooh, 7. And then if we multiply by 100, it gives us the percentage. So 77.4537%, right, of pregnancies, of random pregnancies, but pregnancies, of pregnancies, I think that's plural, has a length, have a length between 250 through 290 days. Let's see. So 77.45% of pregnancies have a length between 250 through 290 days. Not bad. And that was very close to our approximation, wasn't it? Ooh, okay. Yeah. Stretch out a little bit. Pause the video if you have to. Watch those videos. Yes, this is a culmination of everything that we've done, for the past almost 16 weeks. Don't forget, this is almost over. Almost over. All right, let's move on. What is the probability? Well, first of all, we got to read the top part. It says, a particular type of fourth grade achievement test provides overall scores that are normally distributed with a mean of 50, okay, mean of 50, and a standard deviation of 10, okay, standard deviation of 10. All right, what is the probability that a randomly selected student earns a score of at least 42? Okay. So let x equal what? What is it equal to? Test provides overall scores. Okay, scores. Okay. So let's fill this out on the bottom. 50 is down here, right? 50. Let's see, let's make that bigger. 50. And then we're going to add, what, 10 to it? 60, 70, right? 40, 30. That's really cool. Really easy. And we want to know what the probability is. What's the probability that a random selected student earns a score of at least 42? of at least 42. What is that word, at least? What is that? Some of you be like, at least. Okay, least. I guess. We'll just do it that way. Okay, let's go. It doesn't really matter where the arrow goes, the inequality. Of course it does. That's why I gave you the conversions of symbols to words or words to symbols, right? Look it up. Don't assume, right? Do you remember, or for some of you, you might remember this, when you were kids, they told you at least take out the trash, right? With a little bit of being mean to you. They didn't say please, but still, they said, hey, at least take out the trash. What do you think that meant? At least. Can you do less? No. You got to do that and more, right? So at least is greater than or equal to 42. Okay. And so what is, like if we were shading it, what would it be? 42. Oh boy, where's 42? 42 is somewhere there. That's where we can start. And it goes all the way where? It's right to infinity. Okay. Ooh, right, that's better. This is the fun part. We shade all this. Now, this piece right here, this piece is not 34, right? What would you say it is? It's not half of 34. What do you think it is? Maybe 25%? Maybe? 25? I'm not sure. But it's not 34. It's not 34%. This is not 10% because it's not even half. It's not 18% because it's not half. So, it's about 20, 21% or something. Okay. We'll say this is about 20. Let's do 23%. Okay. We'll just guess. Then this piece is definitely 34 because the inequality doesn't say to stop at 60. Right? Don't forget, I failed kindergarten art. So these pictures are, they're okay. They are kind of neat when you draw them and when you have some patience. They don't come out that bad. And if you look at this later in your careers, I think you're going to really appreciate how much time you really spent doing these math problems. Okay, that's not too bad. So 25%, 23%. Okay, so I said 23. So 23, oops, wrong color. 23% plus another 50%, right? Why? This whole thing is 50%. And this is equal to what? 73%. Right? Okay. 73. So, what do we got? Let me move this over. It's a little bit, okay, getting crowded here. And then we're going to do normal CDF probably, right? Normal CDF. We got the lower bound. What's the lower bound? That's right. It is 42. What's the upper bound? Where does this go to? Where does it stop shading? Negative infinity. Not negative, positive infinity. What else? What do we need? That's right, we need the mean, which is 50. And what else? Standard deviation is 10. Well, that's easy, right? So, second vars, normal CDF, 42, comma, positive infinity. Make sure you have 2 nines, comma, 50, comma, 10, close, enter. 0.788144. I don't usually put the 0 there. But if you want to, that's fine. I'm going to multiply by 100 to get that percent. Ooh, okay. What is this? 78%, oh, 78%, right? 78%. That's pretty close to 73. That's not too bad. That's not a bad estimate. Maybe I could have done that a little bit better, but it's really close. Do you need to show the approximation? Yes, you have to. So, what's this 78%? I'm not going around, but I'm just talking in generalities. 78%. What is the probability that a randomly selected student earns at least 42? There's a 78% chance that a student will earn a score, right? 78% chance. So 78.8144% chance. Chance that a randomly chosen student will have an earned score of at least 42. And that's probably the sentence that most people are going to want you to write. But again, this is not a writing class, but try to do your best in terms of describing what's going on, right? 78.8144% chance that a randomly chosen student will have an earned score of at least 42. Right? You see, almost 80% of students, basically this is what it's saying. If you think about it, 84% of students will earn at least 42. See, that's another sentence you can say as well. Not 80, mind you, don't round, but 78.81% of students will earn at least 42. But in reality, you have to say a randomly chose student, because you don't know which student is the one that's going to get at least 42. So you have to randomly choose. It's the idea that you don't know if it's from here or here. So you have to say randomly. You're choosing at random, and you don't know where you're choosing it if you're choosing from here and here. Okay, let's do part B. Ooh, part B. So mu is 50. Standard deviation is 10. Awesome. All right. Let's read. One state wants to allow all students with scores in the top 3% into a special advanced program. Okay. Top 3%. What will be the minimum score required to admit into this program? Top 3%. Okay, so if you think about this, This might look like a kind of like a percentile problem, right? But did it say 3 percentile? No, it did not. So it's not from here to here, which will be 3%. That's not really the case. It says top 3%. Oh, top 3% is over here. Right. This is 3% right here. Top 3%. Okay, good. That needs to be clarified. You see, these word problems can be a little tricky because there are certain keywords they have to look out for. But in terms of all the types of problems that you're going to do, you already know which ones you're going to do. Oh, my battery is almost low. Okay. So let's keep going. Let's, what are we going to do? Are we going to do the normal CDF? No, we're not, right? Because what are they asking you for? What will be the minimum score? That means X, right? The scores, we want the scores from a percent that they've given us to a score, or to a score, right? They want to know minimum score. Same thing, so we go over here, right? They give us a percent, not a percentile, but a percent, and they give us a score. We are going to use percentile, and we got to make sure that we put the percentile in here. But the percentile is a top score. Can we still use the inverse normal? Yes, we can. So first of all, we got to fill this out here. This is going to be what? 50. It's going to be 60, 70, 40, 30. And as you can see, right, if you draw the line, it's going to be somewhere between 60 and 70, more closely to something like 68 maybe is the answer, right? So the answer, so it's going to be very close. I'm going to write it in a different color. So it's going to be very close to, what did I say, 68. The score of 68, right? Yeah. So a score of approximately 68 is my estimate. Yes, you have to write an estimate. All right. And then now we're going to have to do the inverse normal. The inverse, right? Inverse normal. And we need a percentile. But it's not the 3%. Percentile is what? What's percentile again? Do you remember? Percentile is the shaded below. This shaded below. Because percentiles start from negative infinity to where it ends, right? So this blank spot is the thing that the calculator needs as information to calculate this number. Because it's shading from left to right, it's going to shade to here, which is 97% of the date of the scores. And then it's going to tell us this value. Okay? That's the trick. And you got to watch those videos to kind of get the definition of it. So this is 0.97, which is, 100%. Take away 3% is 97%, but these can't be percents. These have to be decimals, right? comma, 50, which is what? The mean, and then 10. Okay, let's do it. Second, bars. What do we got? Inverse normal, 0.97, comma, 50, comma, 10. Close it, enter. Aha, look at that. The answer is 68.807. That's the score. What type of score? The minimum score. So the minimum score required, right? The minimum score required to be admitted into the program is 68.807. Pretty cool, right? Okay, wow. That's a lot. That's a lot of information. But now you know how to do them, right? If you see a mistake somewhere in my thinking, you see some of the numbers wrong or something, tell me, right? And then we can tell everybody else. This is a hard process to do, but with time and effort, you can do it. But you got to listen to like what I'm saying. I'm giving you like the key ideas to do it. And it just takes time. The first time I did this, yeah, I didn't know how to do it. And the teacher, well, it was like read the book, and there was no YouTube. And the examples like I just did right now, nah, you know, it wasn't that much detail or thinking process, right? When I'm doing these, it's about the process of my thinking. What am I thinking? What do I remember from other, things? And that's hard. So keep it up. Be safe. I'll email you soon. Bye-bye.